Hi, welcome to MAT. I put 210 and it's 120. I'm sorry, intermediate algebra. And we're going to discuss section 2.1 briefly, graphs of equations. Should be a review uh, for you. So let's take a look at our graph. This is called a Cartesian coordinate system. It's named after a mathematician named Rene Descartes. Very interesting mathematician. And what he did is he was sitting one day and he was looking at the ceiling, and the ceiling probably maybe had a grid on it or whatever. And he saw a spider. And he was trying to determine if he could describe mathematically where this spider was. And so what he did is he came up with this idea. Later on, Milton Bradley came up with the same idea and called it battleship. And they only used one quadrant. Anyhow, this is the x-axis, and this is the y-axis. And these are the vertical and the horizontal. This is the origin right here, 0, 0. And he realized that he needed 2 points to describe what was happening. And so he put these in alphabetical order, x, comma, y. So they're called ordered pairs because they're in a particular order that we want them to be in. So ridiculous. Was a pretty bright guy. Came up with all this great stuff. So he figured if you're going this way, you have a positive x, and if you're going this way, you have a negative x. If you're going up, you got a positive y. If you're going down, you have a negative y. So we're going to try plotting these points, negative 4, 3. That's saying I'm going to go from the origin, a negative 4, 1, 2, 3, 4, but I'm not going to stop there. And then I'm going to go a positive 3 up, 1, 2, 3. And I'm going to rotate that point right there, negative 4, 3. Okay, how about negative 5, negative 3? Well, we're going to go negative 5, but instead of going up, now I'm going to go down 3, 1, 2, 3. So this was negative 4, negative 3. Let's call this negative 5, negative 3. So the first point is always x and then y. How about this one? These are always tricky, 0, 4. So let's say I'm going to go 0 in the x direction. I'm not going to move. And now I'm going to go up 4 units, 1, 2, 3, 4. So that's the point, 0, 4. Well, how about a decimal, 2.50? This is saying I'm going to go 2.5 in the x direction, but I'm not going to go up. Just going to stay right there. 2.5 x and y. And then the last one, 40. Let's make it a little bit interesting. Well, let's just go ahead with 40. 1, 2, 3, 4. And again, we're not going to go up. Okay, so, you want to practice, make sure you get the points right. If you don't, we have trouble. So let's look at another problem here. And I have a problem here, but I forgot to write the equation. That wouldn't do as much good. I need some more information on this problem. I better put some information in here. So one thing that's really important in math is that you read the directions. It says, show that each pair, that means these ordered pairs, is a solution of this equation right here. Then we want to graph this equation and use the graph. We're going to graph these points, in other words, and we're going to use this graph to find the y-intercept. Okay, so what the heck are they talking about? Okay, this point right here is considered a y-intercept because it crosses the y-axis. And these 2 points over here are called x-intercepts because they cross the x-axis. So any point that crosses the y-axis is a y-intercept. Sometimes we just abbreviate it that way, y-int. And these are your x-intercepts. And again, we could abbreviate them. So those would be your x-intercepts, which I go to face there. Sorry about that. Anyhow, let's try to do what they say. Show that each pair is an equation. How the heck could we do that? Well, what we're going to do is write down this equation, and we're going to substitute this point in. What number, what letter are we going to substitute it for, though? This is going to become x, and this is going to be our y. So in place of x, this would be 4 minus a negative 1, and this would be a 5. So that's interesting. See, I put it in a parenthesis, so this is 5 equals 4, chick, plus 1, 5 equals 5. So that's a true statement. All right, let's try the next one. 3, 1. Y equals 4 minus x. So it's important that we put them in the right place. X is 3, and y is 1. And that looks like a true statement also, huh? So these are 2 points on this graph. This graph is made up of millions of points. So let's draw our axis. You should always label your axis. This is your y-axis. This is your x-axis. We usually put a little arrowheads to show it keeps on going. Okay, so starting from the origin, we're going to go a negative 1 in the x and 5 up. 1, 2, 4, 5. We're out of the room there almost. And on this one, we're going to go 3 in the x direction and 1 down. Hopefully we did this right. And now we're going to draw a straight line through those. I'm going to grab a ruler and go right through these as carefully as I can. See, now this point is made up of millions and millions of points. All these points are answers to this problem, So we want to know where across the y-axis, y-intercept. And across the y-axis right at this point, and the name of that point is 0 for x and 3 for, So it says graph and find the y-intercept. We found it right there. And we want to label it too. Probably should say graph and label. So we want to make sure that we found it. So these were true. And we found all the directions. We checked them out. We drew the graph. And we found the y-intercept. And we identified it, so somebody else could find it. Okay, another thing is we want to graph equations. So when we graph equations, you can use this for any equation. I know you can use the TI-84, stuff like that, and they'll graph them for you. But sometimes you just have to graph them yourself. So we're going to let's make a table a little bit bigger. Okay, this is x, and here I'm going to put my equation, and this is y. So what I'm going to do is just pick, excuse me, you can't even see the problem. I'm going to pick values for x that would work in this problem. I'm going to think of just problems, and I might put some negatives and positives, or, when I'm starting out, I could put 0, 1, 2, 3 if I want, and that's what I'm going to do. 0, 1, 2, 3. You could get by with 2 points. The more points you put, the more accurate you get. Over here is my workspace. This is 2 times 0, which is 0. And this gives me the ordered pair 0, 0. See? Put a 1 in here. I got 2 times 1, 2. I got the ordered pair 1, 2. Y equals 2. 2 is my constant times 2. Maybe I should put these in parentheses. That's the number I'm replacing. 4. So I have the 0.24. Now I'm going to put in a 3. Y equals 2 times 3, which is 6. I had the 0.36. So now I'm going to graph those points and see what happens. I'm going to draw my axis. Make it too big. Come down here. I don't see any negative numbers, so I think I'm pretty safe in doing this. Here's my x-axis, here's my y. I'm going to put in the point 0, 0, well, that's the origin. I'm going to put in the point 1, 2, right there. I'm going to put in the point 2, 4, 2, 4, right there. I'm going to put in the point 3, 6, 3, 4, 5, 6. Notice they're on a straight line. We call this a linear equation because they're a straight line. And equations that don't have any powers are going to be, or they're basically a power of 1, are going to be linear equations. And so this is a linear, and it just is going to keep on going. So we want to identify that with arrowheads to show that this is just a portion of that graph. And every point, and this point, like here, 1/2, 1 is a point on the graph. See, there's millions of points. This is made up of, like on a TV, a lot of pixels that make the picture. Okay, let's try this one. Gotta draw the graph. I think when I'm doing these, I like to, I guess I didn't need a straight edge, but I like to put it this way. Here's my x, here's my equation. That way I've got some room to do some work. And then here's my y. I know, it works for me. Okay, on this problem, it has a fraction. So I'm going to be smart. The fraction is 1/2. I'm going to take multiples of 2. My denominator is 2. I'm going to take multiples of 2. I'm going to use the numbers -2. 0 is always a good number to use, and 2. I'm just going to use 3 points. Okay? Y is equal to, I'm going to just leave that out, -1/2 times a -2 plus 3. See, this way I might not make as many mistakes with my signs. I've got -2 over 2, so that, or I can take 1/2 of 2 is 1. So I got a +1 plus 3, 4. Okay, now I'm going to put in a 0. Well, 0 times anything is 0, plus 3 is 3. You should start to see a pattern. Notice on this one, 0, 2, 4, 6. There's a pattern here. You should see a pattern here. Let's see if it works. -1/2. What do we put in here? 2 and 3. 1/2 of 2 is 1, and -1/2 of 2 is -1 plus 3 is 2. See the pattern? That's why in the book, sometimes they put like 0, then -2, then 2. I like to put them in order because then I can see I've got a pattern there and I can probably identify that I'm doing it correctly. Okay, so I'm going to draw my axis here. Here's X, here's Y. Okay, so I got -2, 4. 1, 2, 3, 4. Right there. 0, 3. Again, a tricky one to graph sometimes. 0, 1, 2, 3. Right there. 2, 2. 2, 2. And if I did it right, they are in a straight line. I couldn't even make predictions about this, what the next numbers are going to be and all that stuff. Try to draw it as accurate. I think I'm off a little bit on my drawing, but, try to get it as accurate as you can. This probably should have been here or something. All right, graph 3x plus 5y equals 10. Here's a problem that is a little trickier to make the table because the x and y are on the same side. We can use a method called intercepts, but I'm going to show you how we normally graph this, and that's to rewrite it in terms of y. So the first thing I'm going to do is add a -3x to both sides. Then I cancel out this 3x. I like to put the x term first and then the number. Okay. So I'm going to get this 3x. Sometimes I say change sides, change sides, change sides, change sides. Or cross the line, change the sign, whatever. Then I'm going to divide everything by 5. Cinco, cinco, cinco. So y equals, I can't divide that. I don't want to use those decimals. I want to keep this with a fraction. Plus 2. Okay. So I'm going to make a table of values right here. Should have enough room. See, I'm going to write this one down right here. -3 over 5x plus 2. And once again, because I should have put it on the top there. That's okay. I should have filled it in there. Anyhow, I'm going to use multiples of 5. That's my denominator. -5. And I could use 0 again is a great number, and 5. I could have used 0, 5, 10. You know, that's a good choice too. So I got -3 times a -5 divided by 5. What would that be? -15 divided by 5, -3 plus 2. A -3 plus 2 is a -1. There we go. I put it on the wrong line. Okay, I'm all confused here. So let's put the -5 here. Okay, let's call this 0. All right, here we go. 3 times 0, 0. Divided by 5, still 0. Plus 2, 2. Running out of room. Let's put in a 5. That should have been a -3. Wait a minute. Was this a -3 times a -5? That's a +15. Divided by 5 is 3. 3 plus 2 is 5. Messed up. Okay, now let's try a +5. -3 times 5 is -15. Divided by 5 is -3. Plus 2 is -1. That makes sense because they're coming down 5, 2, -1. Maybe hard to see the pattern, but we're subtracting 3 each time. All right. So math, we're always looking for patterns. I'm going to make this one a little faster. All right, so let's try graphing it. -5, 5. I almost missed it on this one really bad. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. Way up there. -5, 5. 0, 2. 0, 2. Not a very good graph, huh? And 5, -1. 5 in the x. 1, 2, 3, 4, 5. -1 down here. If I did it right, straight line. Okay, the last graph I have here is a quadratic. It has a power of 2. So anytime they have a power in them, they're not going to be a straight line. They're going to be some kind of a curve. So this one's going to be a curve. And later on, I'm not going to spend much time on these because later on we're going to spend a great deal of time. But we're going to do the same thing. Anytime you want a graph, you make kind of a table. This one we might have to make a lot of points. Let's make this table correct for a change. And 1. There we go. So I'm going to use some negative numbers, some positive numbers. Yet I don't know exactly where this graph is going to be. So I'm just hoping, sometimes if you don't graph enough numbers, you don't get a good looking graph. But I'm going to try the points -2, -1, 0, 1, and 2. I'm going to try those numbers and see how we come out. So y equals a -2 squared, 4, +4, -5, 4 minus 5, -1. So I said I'm putting it in, I'm calculating. Y equals a negative 1 squared, which is 1, minus 5, which is a negative 4. 1 take away 5. Y equals 0 squared, 0, minus 5, negative 5. Y equals 1 squared, 1, minus 5, negative 4. Y equals 2 squared, 4, minus 5, 1. 4 minus 5, negative 1. Okay, if you did it right, there should be a pattern. Not the same pattern as a linear equation, but there is a pattern. Now, it looks like y comes up with a lot of negatives, so I'm going to draw my graph kind of like this. Here's my x-axis, and here's my y-axis. So, when x is negative 2, y is negative 1. When x is negative 2, y is negative 1. When x is negative 1, y is negative 4. 1, 2, 3, 4. When x is 0, y is negative 5. When x is 1, y is negative 4. And when x is 2, y is negative 1. Pretty nice looking. We're going to try to trace this in carefully. Graph is coming down like this. It's kind of turning right here. Then it's coming back up. I'm sure some of you can do a little bit better picture than me. And it's coming up like this. This is called a parabola, this particular curve. So a curve like this, and we'll be doing a lot of work with parabolas later on in the next course. But, just to give you an idea. So no power, straight line. You throw in a little exponent here, a 2 or a 3, then all of a sudden the graph does these kind of crazy curves. So I hope you enjoyed this one. It's kind of a shorter one, I hope. And then next time we'll talk about some functions.